Okay, let's take a look at some of the properties of exponential functions. We saw that basically no matter what case we had, it was either going to go like this, right, and flatten out over here, or it was going to go the other way and flatten out over here. And because of this, we can talk about the domain. The domain, remember, is all the places where all the x values that our function is defined. So if we look at either one of these pictures, we can plug any x value we want into the function and it'll give us a result. So our domain, or the domain of any exponential function that has this form, is going to be negative infinity to infinity. Now let's talk about the range. The range are the y values. So where on the y-axis can we look to the left and right and see part of our graph? Well, it's obvious that above the x-axis we always have a picture. Below the x-axis we don't. And on the x-axis, remember, since we never touch it, we don't have anything. So it's everything greater than 0. So we'd say everything from 0 to infinity, put a parenthesis on the 0 because we do not include 0. Now, is your function going to be increasing or decreasing? Well, increasing is this case, right? As you move from left to right, you're going up. Decreasing is this case, left to right, you're moving down. Well, it's only going to increase if the a on the base is greater than 1. If your base is greater than 1. It will decrease if the a is less than 1, and of course greater than 0, but less than 1. How about a horizontal asymptote? No matter which case, it's going to taper off towards the x-axis. So in that case, we can say the horizontal asymptote will always be the x-axis. And then the last thing is to look at the y-intercept. All of our exponential functions always pass through the point 0, 1, so that's our y-intercept, 0, 1. So those are the properties of exponential functions of the form f of x equals a to the x, where a is greater than 0 and not equal to 1.